Good day, everybody. How are you all? Today we are going to talk about least square regression line equation. So I'll share my computer screen with you. Says the relationship between years of schooling and median hourly wage gain percent is given by the following data set. Here's years of education or years of schooling is X, and median hourly wage gain percent for additional year is Y. So we have to find the equation of the least square regression line. Okay, so let's move this a little bit and create some space for us. So we will be use TI-84 calculator. Use TI-84 calculator. So first, clear the memories of the calculator. Memories of the calculator. How to do that? So press the second button on the top left, then the plus button on the bottom right corner on top of the enter button, and then 4. And you get clear all list on your calculator screen. Then hit enter and you get done. Okay, this is the first step to clear the memory of the calculator. So second button, then the plus button on top of the enter button at the bottom right corner, then number 4, which gets clear all list, then you'll hit the enter, done. Okay, now we are going to enter the data in X data in L1 and Y data in L2. So enter X data in L1 and Y data in L2. How do I do that? Well, we press stat and then select number 1, which is edit. And then enter X data in L1, Y data in L2. Stat 1 is edit, X data in L1, so 12, 13, 1, 3, then 1, 4, then 1, 6, then 1, 7, and then 1, 8. After you are done with the last data point in X in L1, you hit the right cursor key. After entering the last number in L1, use this key. This is called the right cursor key to move and put some more space to move the cursor to the first line in L2, to the first line in L2, where we will enter Y data. Enter Y data. Y data. Okay. What are the corresponding Y data? 10, 11, then 1, 3, then 1, 6, then 1, 8, then 1, 9. Okay. Okay. Now we have entered the data in L1 and L2. We are ready to do the calculation. So I will create some space here. Okay. Let me change the color of the ink too. Okay. So next step is press the stat button and then highlight calc on the top row. And then scroll down to number. So start button, then highlight calc, and then scroll down to number 4. Scroll down to number 4, which is reg, means linear regression AX plus B. AX plus B. Okay. Okay. So my X list is L1. My Y list is L2. Okay. And my next line is the frequency list that should be empty. So if you have anything over here, hit the clear button to clear this line. Okay. Where is the clear button is the third row of keys. So like in my case, frequency list is L2. I do not want anything over there. I press the clear button to remove it. And then I go down to calculate. Okay, so go down to calculate and put the cursor on calculate. Okay, and hit enter. Okay, calculate and then enter. Okay, so you get the regression line equation, which is, I'll write over here, least square regression line equation. Regression line equation. Line equation is y hat is equal to A is 1.571. This is the coefficient of x. This is the slope. And then the B, the intercept is negative minus 9.07. So this is your least square regression line equation. Y hat is the predicted y. Predicted y. Okay, this is your predicted y. Predicted y. That's y hat. This is to be read as y hat. Predicted value of y. Okay. Then they say find the value of the correlation coefficient and coefficient of determination. So let me move this up. And that's on the same screen when you did the regression. So that is part C. Okay, so part C. R is the correlation coefficient. R is equal to, so let me clean this up a little bit. Okay. So part C is R is equal to, in the last line is 0.997. This is your correlation coefficient. Correlation coefficient. And it shows a strong positive correlation between X and Y. Correlation between X and Y. Between X and Y. Okay, so that's your part C. Now I will further move up and get R square. So part D is R square. And R square is also on the calculator screen, is equal to, R square, by the way, is called coefficient of determination. Coefficient of determination. Okay. And R square is, in this case, 0.99 0.9948 or approximately 0.995. Only for R square, we multiply it by 100%. When we multiply it by 100%, decimal shifts 2 parts to the right, 2 places to the right. or 99.5% R square value of the variation in Y can be explained by the least square regression line equation. Explained by the least square regression line equation. It's very good because only 0.5 cannot be explained. The rest of it can be explained. That means as x increases, y is also increasing. And there is a positive correlation between x and y. Okay, now let's go back to the last two parts. Last two parts, predict y for x equal to 15. And if the actual value of y when x is 15 is 14, what is the error? So remember the regression equation, we have to work with that. So let me use another color just to make life a little interesting. So part E, y hat when x is equal to 15 is equal to 1.571 times 15 minus 9.07. Just make sure that I have taken the correct x value. So I'll move up a little bit and make sure I'm doing. Yep. Okay. So that is equal to y hat means predicted y, and I can use my calculator is 1.571 times 15 minus 9.07, and that is equal to 14.45, you might say. So that's your predicted y. Now in part F, they give y actual when x is equal to 15 is 14. So and they ask what is the error. So we have to calculate the error. The error is y actual minus y predicted or y hat. So actual is 14 minus y predicted is 14.45. So the error is equal to minus 0.45, very small error. Again, error is y actual minus y predicted. So 14 minus 14.45, error is 0.45. So I'll stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, please give me a thumbs up. I really appreciate that. And if you like this video, please share it with your friends. And you and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom of the or at the right corner of the screen. And you can email me at sn_88@hotmail.com if you have any question. Okay, sn_88@hotmail.com. Okay, see you next time. Take care. Have a nice day. I'll come back next time with another interesting problem, interesting solution. See you. Take care.